The hardest code to work isn't complicated code. It's unfamiliar code. And AI is surprisingly good at making the unfamiliar feel familiar pretty damn fast. And that's what this episode is going to be about. So let's imagine that you just joined a new project. And this new project can be a desktop app, it can be an Android app, embedded system, whatever. It doesn't matter. You're going to be looking at the code for the very first time. And after a week, or maybe sometimes not even a weekend, you already have a ticket. You have something to implement, you have a module to extend, you have a bug to fix. And the person who wrote that in the first place, the person who wrote the base, doesn't even work there anymore. So you look at the codes, there are no comments, there's no documentation whatsoever. The function names kind of make sense, but you don't really know what they do or why they were built that way. And basically, as a human being, you could spend 2 or 3 hours reading everything, debugging, tracing execution, or you could do something else. You could open a chat with your AI and ask it to explain the code as if you've never seen the project before. And then about a minute, sometimes not even a minute, you get a clear summary of everything you need to know to get started. So let's get into it. So welcome to the third episode of Human in the Loop, this one with some sort of delay. This week was a busy one. However, today we're going to be talking about how most developers spend more time reading code than actually writing it. Because they are inheriting existing code bases, they are onboarding onto new themes, they are picking up all finished features. Because that's the job nowadays. You're always building on top of something that already exists. So the first thing you need when you see unfamiliar code isn't knowing what to change. So let's imagine you have a ticket, you know you have to do something, and you know what you have to implement, you know what bug you have to fix. But most importantly, you've never seen the code before. You need to know what it does, and you don't need just the theory. You don't need to look at the function name and know what it does. No. You want to understand how it actually works. Why are there so many if conditions? Why is this called this way? Why does it depend on another function above? It's not something that you get from a simple UML diagram. So the move on this episode, we're going to be talking about how you can open a chat with your AI and ask it to explain the code like you've never seen the project before. And here's an important distinction. You do not, and I repeat, you do not ask for a summary. You ask for an explanation, because a summary gives you what you might already know. And an explanation is going to tell you what it does and why it matters. So that's how you should do it. There are 3 variations that are very worth knowing. Okay. So there's 3 ways that you can ask your AI agent to perform this explanation for you. So the first one, you have the plain explanation, which is you ask, explain what this function does step by step in plain language. And it's just that. That simple sentence alone gets you surprisingly far, even on gnarly spaghetti code. So just explain what this function does step by step in plain language. Then the second one, the dependency map. So you ask your AI agent, what does this depend on and what depends on it? And it's another simple sentence, right? But it gives you a blast radius before you even touch anything. So if you're working on the front end and you need to interact with a back end that you can't even run locally, for example, AI can explain to you what the API does on the other side. So you don't need to be, pulling in a colleague from the other team just to understand the shape of something. And last but not least, you have another one, and this one is a nice trick that you can use when there are variables that are hard to understand. Even, and sometimes even the ones that are easy to understand, this is really useful. So it's called renaming and clarifying. And what you do is you open the chat and you ask, if you were naming these variables and functions clearly, what would you call them? And just something like this, it's especially useful when you're dealing with variables that are, named ABC, for example, but also when they are already sort of named decently. Because, a lot of developers still have there's a lot of code bases nowadays that still have terrible variable names. So AI can actually decipher these for you. And asking AI to rename it or to rename the variables will force it to actually reason to what those variables actually do. And on a quick note, now that we've talked about these three things, this isn't just for code. So this works if you're a PM, for example. If you inherit a spreadsheet from someone that already left, and you look at the spreadsheet and it has 40 tabs, it has no documentation, it has columns named, final V5, final V4, whatever. You can paste a section of it into AI and ask it to explain what it's tracking. Because nowadays, most AI tools already have, for example, Excel or Google Sheet integrations. So they can even walk through the whole relationships between tabs for you. So it's the same idea in a complete different context. Like I said, you don't need to do it just on code. But anyways, going back into code, once you know what the code does, the harder question that you have to ask yourself is, why does it do it this way? Because here's the thing, the decision that looks wrong. So you look at the code and you see a bunch of spaghetti that almost makes no sense, right? You look at it and that decision that someone took made sense at the time, but you have no idea to know. Maybe because that person isn't in your company right there. But, code that exists right now was useful to someone at some point. So your job before actually changing it is to understand why it was made that way. Why was it decided to be implemented that way? Why was the implementation that certain way? And this is where a lot of developers skip steps. And we're talking about before AI was even a thing. Because people will look at the function, developers will look at a function, they see it doesn't do what they expect, and they might remove something because it looks unnecessary for what they're implementing. But sometimes, and as a matter of fact, most of the times, it's a mistake because the code was there for a reason. And, as a developer, you're going to see spaghetti code constantly, every single day, every day you work your job. And sometimes you are going to look at your own code from a year ago and wonder, what the hell was I thinking? So even then, it made sense a year ago. So before you actually judge it, understand it. And putting AI into this, the AI move here isn't to ask, is this good code? No, it is to ask something like, what problem does this approach solve that a simpler approach wouldn't? Or maybe something else like, what trade offs was the original author of this code probably navigating? And you're basically, with one of these two questions, or even both of them, it reframes the code to something that, from something to judge into something that you can understand. So, to be honest, AI is also going to be guessing a little bit here. So, you can never forget that. But unless AI has access to your Git history or your Jira or your Azure DevOps, which nowadays is actually possible. So you can have these integrations working, which will probably help you a lot in understanding the code. But if it doesn't have access to these things, it's going to be doing pattern matching. That's all. That's what LLMs do. So it has seen decisions like this before, and the reason that it's going to do is going to be, from pattern matching once again. So it's going to look at these things and it's going to tell you what they usually mean. And it might be wrong, but the point is, you are going to spend 2 hours doing this by yourself anyways. And AI is going to do it in a minute. And, at least it points you in the right direction. Even if not everything is right, maybe 65% will be correct. So this is the good thing about AI. And there's a useful follow-up here, which is, you can use the AI's output. Like, you don't even have to use it for a final decision. No, you can bring it to a colleague. If you work with someone else, you can use what the AI gave you. So you do not use it as a definitive answer. You're going to be using it to start the conversation fast. So you turn to your colleague and you go like, I think this was built this way because of this and that. So do you remember something like this? And just like that, AI helped you, start a conversation. So now you have two brains on it. You have you and your colleague, and a third brain technically, because you got AI. AI is also going to be there to answer your questions, to answer yours and your colleagues' questions. And basically, after you're done with this, and after you already have plenty of information, the most important part comes, which is, where do I make my changes? Where do I change this function? So once again, you have a feature to implement, you have a bug to fix, but where exactly do you touch it without breaking something else? So there are two prompts that I'm going to give you that kind of earn their keep here. So first of all, you can use this impact question. You can turn to your AI and do something like, say something like, I need to change this function. Based on what you can see, what else might this affect? And this is working like a pre-flight, basically. So it's a pre-flight check before you even start messing with something. And once again, always have to remember this. It won't catch everything. It's going to see what you give it, because from past episodes, context is important. And at the same time that you don't have context about this new code base, AI also doesn't have it. So once again, it's not going to catch everything. However, it's going to catch the obvious stuff. And just that alone serves you a lot of pain. It saves you a lot of time. And then after this one, you can go with the entry point question. You would do something like, where would you make this change and why wouldn't you make it here? Okay. So in this scenario, you already have some sort of idea of where you need to, mess things up, where you need to touch, but you ask AI for the entry point question, like, where would you make this change? Would it be here where I'm thinking? Why not somewhere else? And this is useful when you sort of already know the answer. You sort of already know what function you need to change, but maybe you need to touch function A, but when you ask AI where it would make the change, it might say something like, this could be the output from the AI. Actually, if you change it and a function B instead, you avoid a side effect in function A. And that's the kind of thing that saves you a debugging session. So instead of straight up going to function A and messing with it, ask what about function B? Because look, if you do it on function B instead, you can do things a lot easier, and the entry parameters are actually easier this way. And these two prompts together that I just gave you put you well ahead of where most developers are operating right now. And the output from both of these questions can be used the same way as before. So once again, it doesn't need to be a definitive answer. You can bring it to a teammate. You can start a conversation. You can get a second, a third, a fourth opinion if you work in a larger team. So if there's no colleague available, obviously you still have the exploration time that you're going to do. But if you have colleagues, use your colleagues as well. Like in a good sense, use your colleagues to start conversations with what AI is giving you. Because, things might actually register in their heads differently from what they register in yours. So taking a few steps back from something that we talked about in the previous episodes, because it applies even more here. But the brief always matters. You should always give AI more context than you think it needs. And I don't mean just, give it the function and, no. Give it something like, this function right here is called here, and I need to implement this, or I need to fix this. The expected output is this. The more reasoning material you give it, the better the output. So like we talked about on the past episodes, the quality of the output equals the quality of your brief. Never forget this. This works for everything. And when you're working with unfamiliar code, AI's answers are more likely to be plausible but wrong, because it's also working from incomplete context. If you don't have the context, AI is also not going to have it. So your job when the output comes to you is to always verify. If something looks off, trust your instinct, because you're the one who reasons. You're the one who makes the final call, not the AI. So never, never forget that. So let's wrap things up real quickly. Three things in order that this episode covered. On the first part, we talked about what does it do. So get the plain explanation first. Ask for a step by step, not a summary. Then the second part, we talked about why was it built this way. So always understand the decision before you judge it. Ask what problem it was solving. Ask why that spaghetti code was solving something. What was it solving? And last but not least, where do I change it? So using AI as a pre-flight check, not a guarantee. And it's an impact question and then an entry point question. Okay. So once again, the decision is always yours, not the agent's. And the quieter win here is AI helps you understand existing code faster than any other tool available right now. You could spend 3 hours reading through everything, even if it has documentation, even if there's comments on the code, or you could open a chat, get oriented in a single minute, and spend those 3 hours actually building. That's the goal of this episode. Thanks for listening, and I will see you on episode 4.